Hi guys, welcome. We are on day 18, and today we are going to be looking at lessons 51 and 52. So, lesson 51, we're rounding decimal numbers. So, just like rounding any numbers, we're going to look at whatever place value we're trying to round to, and then the value directly to the right, and that'll tell us whether we round up or whether we round down. Again, if it's 5, 6, 7, 8, 9, we round up. If it's 4, 3, 2, 1, or 0, then we round down. All right, so money is a great example since we operate, in dollars and cents, and 1 cent is 1/100th of a dollar. We take it out to two decimal places because we don't have anything smaller than a penny. We can't take it out to the thousandths or 10,000ths of a penny. So we round to the nearest two decimal places whenever we're working with money. So example one, I said Dan wanted to buy a book, $6.89. Tax was 8%. He calculated the sales tax. He knew that 8% was 0.08 or 8 over 100. And he multiplied that. Again, I would probably use the decimal version when we're doing these problems for ourselves, just because money we use decimals, so it makes more sense to end up with decimals than a fraction. But anyways, we multiply it out, and this would be what we're paying in tax, but we don't have anything, any sort of currency or coins for our thousandths or 10,000ths place. So what we do is we round. So we have 1, 2 decimal places. So we want to round this value to two decimal places. So that's our second decimal place. We look to the value to the right. It's a 1. So that tells us we round down. So 55 cents would be how much we pay in taxes, or in sales tax for this purchase amount. Sheila, example 2, Sheila pulled into the gas station, filled the car's tank, 10.381 gallons of gas. Around that amount, she purchased to the nearest tenth of a gallon. So again, we're going to look at the tenths place, which is 1. We're going to round it to 1 decimal place. So we're looking here. The value to the right is an 8. So that tells us we round up. So that 3 is going to round up to 4. So it becomes 10.4 gallons of gasoline. Again, that's if we're rounding. We're told to round to whatever decimal place. Like pi is a great example. We use pi for our circles, circumference, and area of circles. And we usually round it to 3.14 because it's a decimal that goes on infinitely. So we have to round it at some point. So there's some computer programs. I've taken it out to millions of decimal places. Some people have studied it out to memorize it out to 1,000 plus decimal places. I would never do that to you guys. So we're going to round it to 2 decimal places. So again, versus going on and on and on, we're going to get an idea of what the number is based on our ability to round. So same thing we did, even if it's to the left of the decimal place, if we're rounding to the nearest millions place or billions or thousands or tens or whatever, we look at that place value and then the value to the right. It doesn't matter what comes after. Like this one, we rounded up to 4 because the value to the right was an 8. And it doesn't matter if 1, 5, 2, 3, whatever comes after this, it doesn't matter because we're just looking at this value. Okay, so it doesn't matter what's 2, 3, 4 places to the right. It's just the one immediately to the right of whatever place we're rounding. And then we use rounding a lot of times for estimating products, quotients, differences, sums. So, and we only do this if we're told to estimate. We don't just arbitrarily round numbers and use it to calculate, because we only do it if we're told to do so. So like in example 3, you'll see examples like this on your test, your reviews. It says to estimate the products. That means we're multiplying by rounding the numbers to the nearest whole number before we multiply. So 6.85, value to the right is an 8 of our ones place. So that's going to become 7. 4.22 means we're going to round down to 4. Okay, so we're going to have 7 times 4. So it's about 28. Not equal 28. We wouldn't say it equals 28, but it's about 28. And we do that through our rounding. Okay, practice set we'll go over together. Second one we're going over today is lesson 52. Okay, and we're mentally dividing decimals by 10 and 100. The nice thing about anytime it's base 10, 10, 100,000, and so on, we just have a 1 and a bunch of zeros. We know when we're multiplying or dividing, we're really just moving the decimal place. If we're multiplying, we're moving it to the right based on how many zeros we have. If we're dividing, we're moving it to the left. So if I have 12.5 divided by 10, okay, well, we could go through and do that. 10 goes into 12 one time, 2 left over. 10 goes into 25 2 times. With 5 left over, 10 goes into 55 times. So we can still do the calculation, but if we remember this rule, it'll make life a lot easier, because anytime it's 1 and 1, 2, 3, 4, 5, however many zeros to the right of it, and it also applies to dividing by these same numbers, we're just moving the decimal the opposite direction, as we see right here. So multiplying or dividing, we're just moving the decimal to the right if we're multiplying, and then how many times we move it is based on how many zeros we have. And then dividing, same thing. So we had 1 0 right here, and then you notice 12.5, well, we move this decimal to there, and now it becomes 1.25. Instead of 12.5, it's 1.25. So all we did is move that decimal from here to here. And we moved it one place to the left because we were dividing by 10. We had 1 0. If we had 100, we're dividing by 100. That's 2 zeros. So we move it 2 places, 1, 2. And then we end up with 0.125. So that's where you get kind of the hang of this and get a rhythm. It makes it really easy, because a lot of times you can just do it mentally, just see a problem and kind of shift the decimal in your head. You don't even have to do it by hand. You don't even really have to use a calculator. It's very, very quick and easy once you have it down. We're just moving the decimal. So let's look at this one. We're 37.5 divided by 10. I have 1 0. I'm dividing, so I'm going to move this decimal one place because I have 1 0. I'm going to move it to the left. So it's going to become 3.75. 3.75, if we took this, move down here, divided by 100, well, then I'm moving it 1, 2 places to the left because I'm dividing by 100. I have 2 zeros. Okay, so I'd move it 1, 2, and then that would give me a blank space. So I would end up with 0.0375. So what I mean by that blank space, if I have so 3.75 divided by 100, I'm moving 2 places to the left because I'm dividing by 100. So I go 1 and 2, and then I fill in my decimal, and then there's an empty space right here. So anytime we have that, we fill it in with the 0. So it becomes 0.0375. That's our new answer. So again, if there was 3 zeros, 4, 5, 6, 7, we'll use this a lot down the road with scientific notation for really small and really large numbers, this principle. So just remember, whatever this is, or jumping a little bit ahead, we can write 100 as 10 squared. So if we have exponents, that's the number of zeros we would have, so that's the number of times we move it. We're dividing to the left 2 times. If we were to multiply it by 100, this was multiplication, then we move it 2 places to the right. So again, this becomes really, really nice because we're working with decimal numbers. And yes, we are multiplying and dividing, but we're really, when we do that, we're just shifting the decimal place to the right, however many zeros we have, whatever base 10 it is, or to the left, however many zeros we have. So it becomes a pretty quick calculation. We don't have to draw it out by hand. We can put it into our calculator. We could do all those things, but if we remember the rule, it makes it a lot easier. All right, practice set. We'll go over together when we return. We will see you guys. Thank you.